Ever typed something into one of those AI language models and felt like you were, I don't know, crossing your fingers, hoping for something brilliant, but maybe getting something, well, less brilliant?
Oh, absolutely, it
Oh,
happens. But it turns out you can really steer these incredibly smart systems with the way you phrase your requests.
right. It's all about crafting what people call prompts.
Exactly. These models are like powerhouses of language, but they need clear directions to really show off what they can do. And that's where this idea of prompt engineering comes in.
Sounds maybe a bit technical. Engineering.
It might sound like rocket science, but honestly, it's really about smart communication with AI. And it's something anyone can learn to do better.
Okay, good. Because that's our mission today, isn't it? We've got this fascinating Google white paper that really digs deep into the techniques of prompt engineering.
Mhm.
And we're going to try and pull out the most valuable insights for you, the listener. Think of this as your maybe express ticket to getting amazing results from these tools
Yeah, tools that are evolving super fast.
without getting totally bogged down in jargon, hopefully.
We'll try. At its heart, just remember that these large language models, LLMs, they basically work by predicting the next word, or technically, the next token in a sequence.
Right, based on all that text they were trained on.
Exactly.
Hmm.
Massive amounts. So clever prompting is really about guiding them to predict the right sequence of tokens to give you the answer or the output you're actually looking for.
And a token isn't always a whole word, is it?
Good point. No, it could be a whole word, sometimes just part of a word, or even like a single punctuation mark.
Which is useful for a surprisingly wide range of stuff, right?
Oh yeah, we're talking summarizing really long documents, translating between languages, writing computer code,
Code generation. Okay.
and even tackling some pretty complex reasoning tasks. It's quite versatile.
Okay, so beyond just getting the wording of the prompt perfect, what else can we tweak? Are there other settings?
Yes, definitely. Alongside crafting the prompt itself, it's really crucial to understand the configuration options, the settings that come with most LLMs.
Ah.
These give you another layer of control over the text the model generates.
Like what specifically? Give me an example.
Okay, let's start with output length. This one's pretty straightforward. It controls the maximum number of tokens the model will spit out in its response.
So you can stop it rambling.
Sort of. But the key thing to remember is that just telling it to be shorter doesn't automatically make the output more insightful or concise. It just stops, cuts off when it hits that limit.
Ah, so it's more like an abrupt ending rather than a nicely summarized point?
Precisely. It's not asking for conciseness, it's just a hard stop. And keeping an eye on this is especially important for some of the more involved prompting techniques we'll get to later, like React.
React. Okay, we'll come back to that. So the model doesn't just keep going after it's found the answer.
Exactly. You want it to stop when it's done the job.
Got it. What other knobs can we turn?
All right, next up are the sampling controls. Now remember, LLMs are predicting probabilities for what the next token should be, right?
Yeah, the likelihood of the next word or token.
Sampling is how the model actually chooses which of those possibilities becomes the next part of the response. And there are a few key settings that influence this.
Okay, like temperature. I've definitely seen that one floating around.
Exactly. Temperature is a really interesting one. Think of it as the models. The creativity dial.
Okay, I like that. A creativity dial.
Yeah. A lower temperature, something closer to 0, makes the model more predictable, more deterministic. It'll almost always pick the token it thinks is the most likely next one.
So very safe, very standard answers.
Pretty much. In fact, 0 temperature is often called greedy decoding.
Greedy because it just grabs the most probable option every time.
Yeah, you can think of it that way. It's always taking the safest, most predictable path. Now, higher temperatures, they introduce more randomness.
Ah, okay.
The model starts considering less likely options, which can lead to more diverse, sometimes more surprising or creative outputs. It's like it widens the pool of acceptable next words.
So low temperature for when you want a straight, maybe factual answer, and high temperature when you're looking to brainstorm or get something more imaginative, like tuning the imagination level.
That's a great way to put it. Low for facts, high for brainstorming. That's a good rule of thumb. Now, you also might see settings called top K and top P.
Right, yeah. What are those all about? They sound related.
They are. There are other ways to control which tokens the model considers next, basically by focusing only on the most probable ones.
How does top K work?
Okay, so with top K sampling, the model looks at the K, most likely token say, the top 10, if K is 10, and then it chooses from just that limited set.
So a higher K gives it more choices.
Exactly. Higher K means more options, so potentially more creative or varied output.
Hmm.
A lower K makes it more focused, more restrictive, maybe more factual.
And if K is 1?
Ah, good question. Setting K to 1 is essentially the same as that greedy decoding we just talked about. Only one option.
Okay, makes sense. And top P, how's that different?
Top P, which is sometimes called nucleus sampling, is a bit different. Instead of picking a fixed number of tokens like top K, it selects a group of the most likely tokens whose combined probability adds up to a certain threshold, P.
So P is a probability value, like 0.9.
Exactly. P is a value between 0 and 1. So it might pick the top 3 tokens if their probabilities add up to zero point 0.9, or maybe the top 5 if needed to reach that threshold. It's dynamic.
So K is a fixed number of top choices, and P is a cumulative probability threshold.
Precisely. Often, the best approach is just to play around with both top K and top P, maybe separately, maybe together, see what works best for your particular task.
How do they interact if I set all 3?
Right, good question. So if you have all 3 available temperature, top K and top P, the model first filters the potential next tokens using both the top K and top P rules. It finds the tokens that satisfy both conditions.
Okay, narrows it down.
Yeah. Then it applies the temperature setting to randomly select from that filtered group. If you only have, say, top K available or only top P, then only that filter is used.
And if temperature isn't an option?
Then the next token is just chosen randomly from the candidates that pass the top K or top P filter.
What about extreme settings, like temperature 0?
Ah, yes. If you set temperature to 0, top K and top P don't really do much because the model's just going to pick the single most likely token anyway. It's deterministic.
And K1?
Same idea. If top K is 1, there's only one choice, so temperature and top P become irrelevant. And similarly, the very, very low top P, like close to 0, usually means only the single most probable token gets considered.
So it's a balancing act. These settings really influence each other. Any general starting points?
Yeah, the white paper does offer some helpful starting points. For results that are relatively coherent but still creative, they suggest trying a temperature around 0.2, a top P of maybe 0.95, and a top K of 30.
Okay.
If you want something especially creative or imaginative, you could crank things up. Maybe temperature 0.9, top P 0.99, and top K 40.
And for less creative, more factual stuff?
Maybe try lower values. Temperature 0.1, top P 0.9, top K 20. And for tasks where there's usually just one single correct answer, like math problems,
Yeah.
start with temperature 0.
Yeah.
That's the recommendation.
That's really helpful, having those ballpark figures to start experimenting. But the paper also warns about giving it too much freedom, doesn't it?
Yes, exactly. It cautions that while giving the model more flexibility with these settings can definitely lead to more varied or creative outputs, it can also sometimes result in text that drifts away from your original prompt, becoming less relevant.
Finding that sweet spot again.
It really is about finding that sweet spot for what you're trying to achieve.
Okay, so we've got a much better handle now on configuring the LLM's output, the settings. Now let's get to the core of it.
Yeah.
The different ways we can actually write the prompts themselves. Where do we start?
Well, the most straightforward way to begin is with what's called general prompting, or often zero-shot prompting.
Zero shot sounds like we're jumping straight into the deep end with no practice.
Huh, not quite. It just means you give the model a description of the task you want it to perform, and maybe some initial text, like a question or the start of a story or some instructions.
But crucially, no examples.
Exactly. 0 examples, the kind of output you're looking for. That's the zero-shot part.
How does it figure out what to do then, with no examples?
Well, because these models have been trained on such a massive amount of text, they often have a general kind of implicit understanding of many different kinds of tasks. They can often generate a reasonable response based just on your description.
Okay.
The white paper has a good example. Classifying movie reviews. You just give it a simple prompt like, classify movie reviews as positive, neutral, or negative review. Then you put the movie review text here, sentiment.
And that's enough, even if the review has tricky wording. I think the paper mentioned one with disturbing and masterpiece in the same review.
Surprisingly often, yes, it can handle that nuance and get the overall sentiment right. The key is just making that task description as clear as you can.
And the paper also suggests documenting your prompts, even these simple ones.
Yes, absolutely. It's a really good habit to get into early. Keeping track of what prompt you use, what settings, what the result was. It's super important, especially as things get more complex.
Definitely. Okay, so zero shot is the baseline. When just describing the task isn't quite cutting it, what's the next level up?
That brings us to one-shot and few-shot prompting. The core idea here is to actually give the model some examples of the kind of output you want.
Okay, so showing it what good looks like.
Exactly. A one-shot prompt includes just a single example. It gives the model one clear pattern to follow.
Like showing it the answer key to one math problem before asking it to solve another similar one.
That's a perfect analogy. And then a few-shot prompt gives it multiple examples.
How many is few?
Usually around 3 to 5 is a good rule of thumb, but honestly, it can vary. Depends on how complex the task is and, importantly, how much text the model can actually take as input the context window limit.
Right, so multiple examples help it really lock onto the pattern.
Yes, precisely. They help the model grasp the structure, the style, maybe the specific format you're aiming for. It makes it much more likely to follow that pattern in its own response.
The paper uses an example of turning pizza orders into that structured JSON format, right? And it included a tricky half-and-half pizza order as one of the examples.
Exactly. Jason, just quickly for listeners, is that standard way of organizing data with key value pairs, like a digital list or table.
Gotcha.
And that pizza example really shows how providing diverse, high-quality examples, including those slightly unusual or edge cases, can guide the model to handle more complex situations and give you that structured output.
So the quality of the examples really matters.
Hugely. The white paper stresses this. Your examples should be relevant, they should be diverse, high quality, well-written, and yeah, include those edge cases if you need the model to be really robust. Even a small mistake or inconsistency in your examples can throw the model off track.
That makes total sense. Okay, so we've gone from 0 examples to 1 or a few. What other ways can we kind of guide the model's overall behavior or output?
So now we start looking at techniques that help set a broader context or even give the model a specific persona to adopt. These include system prompting, contextual prompting, and role prompting.
Okay, 3 related ideas.
Yeah, they could overlap a little bit in practice, but each one has a slightly different main focus. Let's break them down.
All right, let's start with system prompting. What's that about?
System prompting is about giving the language model an overarching instruction, like a meta instruction, that sets the overall context and purpose for the interaction. It's like defining the big picture mission.
So telling it its main job for this conversation, like you are a translator or you are a classifier.
Exactly. You're setting the stage. The paper gives examples, going back to the movie review thing, of using a system prompt to make sure the classification output is always in uppercase letters.
Oh, right, or always comes out in that structured JSON format we talked about.
Precisely. By adding a clear instruction in the system prompt, like always format your response as a JSON object, you can enforce that structure. This is incredibly useful.
How so?
Well, for making sure data comes out consistently formatted, which makes it way easier to use in other programs or databases. It can also reduce the chances of the model just making stuff up, sometimes called hallucinations, especially with structured output.
Okay. Can system prompts do other things?
Yeah, you can also use them for things like ensuring code compatibility or even influencing the model's behavior around safety and toxicity. For instance, including a system prompt like, you should be respectful and helpful in your answers.
Ah, setting the ground rules for behavior. That's really powerful. Okay, so system prompts set the overall goal, the what. What about role prompting? Is that about the who?
You got it. Role prompting is where you assign a specific character or identity to the language model. You're essentially telling it, act as if you are a specific role.
Okay.
This helps the model generate responses that are consistent with the knowledge, the behavior, even the tone of voice you'd expect from that assigned role.
Like asking it to respond as, I don't know, a seasoned book editor giving feedback, or an enthusiastic kindergarten teacher explaining something.
Exactly. The paper shows examples with the travel guide persona. In one, it's just a standard travel guide giving suggestions for Amsterdam. In another, it's told to be a humorous travel guide giving suggestions for Manhattan.
And the output changes significantly just based on that role instruction.
Dramatically.
Yeah.
Defining that role gives the model a kind of blueprint for the style, the tone, the level of expertise it should draw upon. It really improves how relevant and, frankly, how engaging the responses can be.
And the paper even lists a bunch of styles you could assign, right? Like confrontational, descriptive, formal, humorous, a whole range.
Yes, and experimenting with different roles and styles is definitely encouraged. It can lead to surprisingly useful and tailored results.
Okay, so system prompts set the what. Role prompts define the who. What then is contextual prompting?
Contextual prompting is all about giving the model specific details or background information that is directly relevant to the immediate task at hand. It's less about the overall mission or persona and more about the specific situation right now.
Feeding it the necessary background info.
Exactly. This helps the model understand the nuances of your current request and tailor its response more accurately and efficiently.
The example in the paper about suggesting blog articles for a retro gaming website really makes this clear, I thought.
Me too. By specifying that the blog focuses specifically on arcade games from the 80s, the suggestions it gives become much, much more targeted and useful than if you just asked for retro gaming ideas.
Right, because retro gaming could mean anything from Atari to PS1.
Precisely. That added context allows the model to generate ideas that are way more relevant and insightful for that specific need. It leads to smoother, more efficient interactions.
These are all great ways to directly influence the model by setting things up front. What about techniques that encourage deeper thinking or, like, a better reasoning process? I saw step back prompting mentioned in the paper.
Ah, yeah. Step-back prompting is a pretty clever trick. The idea is to try and improve the model's performance on a specific task by first asking it a more general, high-level question that's related to the task. Then, you take the answer it gives you for that general question, and you feed that answer into a second prompt that asks for the specific task you originally wanted.
Huh. So it's like asking it to zoom out and get the big picture before zooming back in on the specific details.
Exactly that. This step back helps the LLM activate relevant background knowledge and maybe some useful reasoning processes before it even tries to tackle the specific problem.
Interesting. Does it help it think more critically?
That's the idea.
Mhm.
It encourages more critical thinking and can help the model apply its knowledge in maybe more novel ways. The paper even suggests it might help mitigate biases sometimes by getting it to focus on broader principles first.
The paper had that comparison, didn't it? A regular prompt asking for a storyline for a first-person shooter level
Right.
versus the step-back approach. That first asked a general question, like what makes an FPS level engaging? Then it took one of those elements, I think it was an underwater research facility setting, and used that context in the second prompt to ask for a specific storyline within that setting.
Exactly. And you can see how that step-back approach potentially leads to a more interesting, more well-thought-out result because it was primed with that broader context first.
That's a really neat way to get the model into the right frame of mind. Now, what about when we need the model to really think through a problem, step by step? That's where chain of thought comes in, isn't it?
Yes, chain of thought, or Cote prompting. This is a really powerful technique for improving an LLM's ability to reason, especially on complex problems.
How does it work?
It basically works by prompting the model to show its work. You explicitly ask it to think step by step or explain your reasoning. This forces it to generate the intermediate steps it took to arrive at the answer.
And that helps it get the answer right more often.
Yes, significantly more often, particularly for tasks involving math, logic, or multi-step reasoning.
Mhm.
By breaking the problem down, it's less likely to make a mistake along the way.
And you can combine copy with those few shot examples we talked about earlier, give it an example of step-by-step thinking.
Absolutely. Yeah. That can make it even more effective. Cote has a lot going for it.
Yeah.
It's relatively low effort to implement. It can be very effective. And it works well with standard off-the-shelf LLMs without needing special training.
Any downsides?
Well, the main one is that because it generates all those intermediate reasoning steps in the output, it uses more tokens.
Ah, so potentially higher costs and longer processing times.
Exactly. But the upside is you get that interpretability. You can see how the model reached its conclusion, which can be really valuable. The core insight is forcing the articulation of reasoning boosts accuracy.
The paper has that great example with a simple math word problem about ages, right? Asking directly gives the wrong answer.
Yeah, it makes a simple arithmetic error.
But just adding, let's think step by step to the prompt makes it lay out the reasoning correctly and arrive at the right answer.
Exactly. It forces it to break down the problem. Calculate the current age, then calculate the future age. As you said, you can guide it even further by providing a single-shot example showing the desired reasoning format.
It sounds like if you, yourself, can explain the steps to solve a problem, then 2T is probably a good technique to try with the LLM.
That's a very good rule of thumb.
What kinds of tasks is it particularly good for besides math?
The paper mentions code generation. Breaking down a coding request into logical steps and mapping them to code. Also, things like creating synthetic or artificial data, where you might guide the model through the assumptions it should make step by step.
Okay, so Qt gets the model to show its single line of reasoning. But what if there are multiple ways to think through a problem? Or what if the first line of thought is wrong? That sounds like where self-consistency might fit in.
You've got it. Self-consistency is a technique that builds directly on chain of thought. It addresses the fact that even with Qt, And LLM's reasoning isn't always perfect or consistent.
So how does it work?
Instead of just getting one chain of thought, you essentially ask the model to generate multiple different reasoning paths for the same problem.
How do you get different paths?
You typically prompt it several times with the same question, but you use a slightly higher temperature setting, remember the creativity dial.
Ah, right, to encourage more variation in the responses.
Exactly. So you get several different think aloud processes, different chains of thought, maybe exploring slightly different angles or calculations.
Okay, so you have multiple Coranti outputs. Then what?
Then you look at the final answer derived from each of those reasoning paths, and you simply choose the answer that appears most frequently. It's like taking a majority vote over the different reasoning attempts.
Okay, so it improves accuracy by kind of averaging out the potential errors.
Precisely. It improves accuracy and coherence.
Uh,
And it can also give you a kind of pseudo-probability. If most paths lead to the same answer, you can be more confident it's correct. The downside, of course, is cost.
because you're running the prompt multiple times.
Right. More computation, more tokens.
The email classification example in the paper seemed irrelevant here, where maybe interpreting sarcasm or tone differently could lead to different conclusions about whether an email is important or not.
Exactly. Different reasoning paths might focus on different cues in the email. By generating multiple COTEs and taking the most frequent final classification, important versus not important, you arrive at a more robust and consistently correct result.
That's a smart way to handle ambiguity. Now, chain of thought seems like a single linear path. Tree of thoughts, though. The name suggests something more branching.
You're spot on. Tree of Thoughts, or TOTE, takes the core idea of COTE but generalizes it. Instead of just exploring one single linear chain of reasoning steps, it allows the LLM to explore multiple different reasoning paths simultaneously.
How does that work? Like a branching diagram?
Exactly like that. Imagine a tree structure. Each node in the tree is a thought, a coherent piece of language representing an intermediate step. From any node, the model can generate multiple potential next steps, branching out.
And it can backtrack if a path looks unpromising.
Yes, that's a key aspect. It allows the model to explore different possibilities, evaluate them, and potentially backtrack or prune paths that aren't leading towards a good solution.
So it's particularly well suited for really complex problems where exploration or trying different approaches might be necessary, like planning or maybe creative writing tasks.
Exactly. Tasks that require exploration, strategic look ahead, or maybe where the initial steps aren't obvious. It's a more sophisticated reasoning approach than linear cut.
That sounds incredibly powerful for tackling really intricate challenges. Okay, shifting gears slightly. What about when the model needs information that isn't in its training data? When it needs to, like, look something up? That's where REACT comes in, right? Reason and act?
Yes, REACT, which stands for Reason and Act, is a really interesting and increasingly important paradigm. It enables LLMs to solve complex tasks by interleaving natural language reasoning steps with actions that interact with external tools,
External tools,
like a search engine, a calculator, a code interpreter, maybe even interacting with an API.
So it's not just thinking, it's doing things to get information.
Exactly. It's a big step towards creating more capable AI agents. It mimics how humans often solve problems we think. We realize we need some information, we go look it up or perform an action, we incorporate that new info, and then we continue thinking.
The paper mentions it performs very strongly compared to other prompting approaches. How does that cycle actually work?
It works through this continuous thought-action-observation loop. First, the LLM thinks it reasons about the problem and figures out what action it needs to take next to make progress.
Okay.
Then, it performs the action. Maybe it generates a search query for a search engine tool. Then, it observes the result of that action. It gets back the search results.
And then?
Then it incorporates that observation back into its reasoning process, updates its understanding or plan, and decides on the next thought or action. This cycle repeats until it arrives at a final answer or completes the task.
The Metallica example in the paper was pretty cool for illustrating this, where it needed to find out how many children the band members have.
Yeah, that's a great example. You can see the model's trace. Thought. I need to know the current members of Metallica. Action. Search for current members of Metallica. Observation. Gets list of members. Thought. Now I need the number of children for each member. Action. Search for James Hetfield number of children. Observation. Gets number. And so on.
So it's reasoning, acting, observing, reasoning again. Very dynamic.
Very. It's a much more active way for the model to engage with the world or external knowledge sources to solve problems that go beyond its internal knowledge base.
It sounds like, in practice, you need some framework or code to actually manage this loop, to handle calling the tools and feeding the results back.
That's right. You typically use libraries like LangChain or build your own system to manage the state, orchestrate the calls to the LLM and the tools, potentially filter the observations, and keep the whole React process on track. You also need to prompt the model correctly, often with examples, to get it to produce those thought action sequences reliably.
Okay, that's a glimpse into more agent-like behavior. We've covered so many techniques. Now, I remember seeing a section on automatic prompt engineering. That sounds almost meta, like AI learning to write prompts for itself.
That's essentially the idea. Automatic prompt engineering, sometimes abbreviated as APE, aims to automate the often difficult and time-consuming process of crafting really effective prompts.
How does that work conceptually?
The basic idea is to use another language model, an instructor model, if you will, to generate a whole bunch of candidate prompts for a specific task you have in mind.
Okay, so you get lots of potential prompts generated automatically.
Right. Then, you need a way to evaluate how well those generated prompts actually perform on your task. This might involve running them against a set of test cases and using some automatic scoring metrics like BLEU or Rouge scores for text generation, or simple accuracy for classification.
And then you select the best performing prompts.
Exactly. You select the top prompts based on the evaluation scores, and potentially you can even iterate, maybe feed the best prompts back into the generator model to try and refine them further.
So it could reduce the amount of human trial and error needed to find a good prompt, and maybe even discover prompts that humans wouldn't think of.
That's the promise, yes. Reduce manual effort and potentially enhance performance. The paper gives a simple example related to training a chatbot for a t-shirt web shop, where APE could generate many different ways a customer might phrase an instruction to order a t-shirt.
That's a fascinating idea, using AI to optimize how we communicate with AI. Now, the paper also dedicates a good chunk to code prompting. We touched on it, but Gemini can really help with actual programming.
Absolutely. Gemini and models like it can be incredibly valuable tools for anyone who works with code, from beginners to experienced developers.
In what ways?
Well, the paper highlights several key uses. Writing new code from scratch based on a description, explaining what existing code does, translating code from one programming language to another, and even helping to debug code finding and fixing errors.
Okay, let's take this one by one.
Yeah.
Writing code.
Yeah, the paper shows an example of asking Gemini to write a bash script. That's a type of script used on Linux and Mac systems to rename a bunch of files based on a pattern. You just describe what you want the script to do in natural language.
And it generates the code.
Yes. And then, crucially, the paper also shows how you can ask it to explain that code it just wrote.
Ah, that's useful. So you understand what it actually does before you run it.
Exactly. You paste the code back in and ask for an explanation, and it breaks it down line by line.
What about translation?
Similar idea.
Yeah.
The paper shows taking that same bash script and asking Gemini to translate it into Python code. You provide the source code and specify the target language.
Handy if you're moving between languages or trying to understand code in a language you don't know why.
Very handy. And the final piece is debugging and reviewing.
Finding bugs.
Yep. The example involves a Python script that's broken, it has an error. You provide the broken code snippet and the error message you're getting when you try to run it.
And the LLM can figure out the problem.
Often, yes. In the example, it correctly identifies that the script is trying to use a JavaScript function to uppercase inside Python code, which causes the error. It suggests the correct Python equivalent, .upper.
Nice. And I think you mentioned it even suggested other improvements.
Yes. Beyond just fixing the immediate bug, it suggested ways to make the script more robust, like handling file extensions correctly or dealing with file names that might contain spaces. Though, interestingly, the paper notes the response was cut off because it hit the token limit.
A good reminder about that output length setting. So when you get code from an LLM,
Big caveat, always, always review and test generated code thoroughly. LLMs are amazing tools, but they're not infallible. They can make mistakes, introduce subtle bugs, or sometimes produce inefficient code. Treat it as a helpful starting point or suggestion, not a perfect final product.
Very important advice. Now, the paper briefly mentions multimodal prompting near the end of that section. Is that related to code?
Not directly, no. It's an important distinction. Code prompting, as we've discussed, is still primarily text in, text out, where the text happens to be code. Multimodal prompting, on the other hand, involves using multiple types or modes of input together.
Like text and images.
Exactly, or text and audio or even video. You might give the model an image and ask a question about it in text, for example. That's multimodal, going beyond just text.
Gotcha. Different concept. Okay, wow. We have covered an incredible range of specific prompting techniques. Now, to kind of wrap things up and bring it all together, what are some of the most important best practices for writing effective prompts that the white paper really emphasizes?
All right, so pulling it all together, the paper highlights several key things, and maybe the most important one they stress is provide examples.
Back to few shot and one shot.
Exactly. Whenever feasible, use one-shot or few-shot prompting. Giving the model concrete examples is just such a powerful teaching tool. It shows the desired output format, the style, the tone, much more effectively than just describing it often can. It significantly improves accuracy. Show, don't just tell.
Makes perfect sense. What's another key takeaway for best practice?
Design with simplicity. Keep your prompts clear, concise, and easy to understand, both for you when you revisit them, and more importantly for the model. Avoid overly complex jargon or including unnecessary fluff.
Keep it simple.
Yep. The paper even gives a nice before and after example for simplifying a travel recommendation prompt and suggests using strong, clear action verbs in your prompts like classify, extract, summarize, generate.
Good tip. What about being specific? We touched on this with contextual prompting.
Yes. Be specific about the output you're looking for. Vague prompts lead to vague or unpredictable results. Providing specific details, maybe through system prompts, context, or just in the main instruction, helps the model focus on what's relevant and really improves accuracy.
The paper had that Dodone example for a blog post about video game consoles, right? Being specific about which consoles.
Exactly. Don't just say write about consoles, say write about the impact of the Sega Dreamcast and the Sony PlayStation 2. Specificity is key.
Okay. What was the advice on telling the model what to do versus what not to do?
Yes. The guideline is generally to use instructions over constraints.
Instructions being what to do, constraints being what not to do.
Precisely. Positive instructions, write in a formal tone, are generally more effective than negative constraints. Don't use slang. Instructions clearly communicate the desired outcome. Constraints can sometimes leave the model a bit unsure about what it should be doing instead.
But constraints are sometimes necessary.
Oh, absolutely. They're important for things like safety guardrails, do not generate harmful content, or enforcing very specific formatting requirements where you need to exclude certain things. The advice is basically prioritize clear, positive instructions and use constraints more sparingly for specific needs like safety or absolute must-nots.
That's a really helpful distinction. What about managing response length again?
Right. Control the max token length. We mentioned the setting earlier, but you can also do it directly in the prompt itself. Explicitly ask for a response of a certain length.
Like, explain quantum physics in the style of a tweet.
Exactly. Or summarize this article in one paragraph. Giving it a length constraint in the prompt can be very effective.
Nice. What about making prompts reusable?
That's where use variables in prompts comes in. This is super useful. By using placeholders like city or topic, you can create template prompts that are much more flexible and dynamic.
Like the travel guide prompt example in the paper that had a city variable.
Exactly. You write the prompt once with the variable, and then you can easily swap in different city names to get recommendations without rewriting the whole thing. It's especially crucial if you're building prompts into applications.
Makes development much easier. What about just trying different things?
Definitely. Experiment with input formats and writing styles. Don't assume your first phrasing is the best. Try asking as a question, phrasing it as a statement, or giving a direct instruction. Play with word choice, style, maybe try zero shot versus few shot. Small changes can sometimes yield surprisingly different results.
So, iterate and explore. The paper also had a specific tip for classification tasks using few shot.
Yes, a subtle but important one. For few shot prompting with classification tasks, mix up the classes in your examples.
Meaning don't put all the positive examples first, then all the negative.
Exactly. Interleave them. If you group all examples of one class together, the model might just learn the order or some superficial pattern rather than the actual features that define each class. Mixing them up helps it learn the underlying distinctions better, leading to more robust performance. The paper suggests starting with maybe 6 examples, mixed, for classification.
Good practical tip. And these models are always changing, right?
They are. So another best practice is adapt to model updates. Stay informed about changes or new versions of the LLMs you're using. Newer models might have different capabilities or respond differently to your existing prompts. You might need to adjust your prompts to take advantage of new features or maintain performance.
And tools can help manage that.
Yes, tools like Vertex AI Studio, mentioned in the paper, can help you manage, version, and test your prompts against different model versions.
Okay, what about output format again? For non-creative tasks.
Right? Experiment with output formats. Especially for tasks like data extraction or classification, seriously consider asking for structured output formats like JSON or XML, even if you don't strictly need it for system integration.
Well, why? We mentioned consistency.
Consistency is key, yes. But structured formats can also sometimes help produce hallucinations or errors. Forcing the model to fit its answer into a strict schema can sometimes constrain it in a helpful way, making it less likely to generate irrelevant or fabricated information. We saw that in the JSON movie review example earlier.
Interesting. Structure is a way to improve factual grounding. What about working with others?
The paper encourages collaboration. Experiment together with other prompt engineers. Prompting can have variation. Different people bring different perspectives and might stumble upon effective phrasing or techniques you wouldn't thought of. Sharing and collaborating can definitely speed up finding great prompts.
Teamwork makes the dream prompt work. Any specific best practices just for chain of thought?
Yes, a couple of specifics for Cote. First, make sure the structure you ask for has the final answer clearly following the reasoning steps. Second, if you're using Cote with self-consistency, the multiple paths method, ensure the final answer part is very easy to extract programmatically from each path's output so you can do the majority voting easily.
And the temperature setting for Cote.
Yes. The tip there is usually set the temperature to 0 for basic Cote. Reasoning tasks typically benefit from deterministic laudal steps rather than randomness. You want the most likely chain of thought, generally. For self-consistency, you'd use a higher temperature to generate diverse paths, but the reasoning within each path still benefits from focus.
Got it. Keep the reasoning focused. And finally, perhaps the most crucial best practice, but one we often neglect.
Documentation. Document the various prompt attempts meticulously. Seriously, this is so important but easily skipped.
Why is it so critical?
It helps you track your progress, understand what worked and what didn't, revisit your work later, compare performance if you try the prompt on a different model version, and debug issues much more easily. It saves you from reinventing the wheel.
The paper even provided a template table for documentation, right?
Yeah.
Tracking the prompt version if it was okay or not feedback.
Exactly. Track the prompt text, the settings used, temperature tokens, etc., the model version, whether the output was good, okay, not okay, qualitative feedback, maybe links to saved prompts if you're using a tool.
And if you're using those systems that insert external content into prompts, like RA.
Document that too.
Yeah.
Document how the external content is being retrieved and formatted before it gets put into the prompt, as that heavily influences the final output.
And for prompts that get used in actual applications.
Best practice is to save them properly, maybe in separate files within your code base, not just embedded in code strings. And ideally, have automated tests that check if your key operational prompts are still producing the expected kinds of outputs, especially after model updates.
So it really comes back to prompt engineering being an iterative process.
Absolutely. It's a cycle.
Yeah.
Craft, test, analyze, refine, document, repeat.
Wow. Okay, we have truly taken a deep dive into the art and maybe the science of prompt engineering today. We've gone all the way from tweaking LLM output settings like temperature and top KP.
Right, through a whole toolkit of prompting techniques. 0 shot, 1 shot, few shot.
System, role, contextual prompting, the clever step-back method.
Chain of thought for reasoning, self-consistency, and tree of thoughts for more robustness and exploration.
React or interacting with tools, automatic prompt engineering, and even specific techniques for prompting for code generation and explanation.
And hopefully we've seen that really effective prompt engineering is kind of a blend. It's partly understanding the mechanics of how these LLMs work, but also applying creative strategies to guide them effectively.
So the challenge for you, our listener, is to start experimenting. Take these techniques and best practices we've discussed, drawn from that Google white paper, and apply them in your own contexts.
Yeah, whether you're prepping for a meeting, trying to get a handle on a new field, writing code, or just, satisfying your curiosity with an LLM. Give some of these approaches a try.
See what works for you.
It really makes you think, doesn't it? As these language models continue to evolve, and they're evolving so rapidly, how will this role of the prompt engineer itself adapt? What new ways will we discover to communicate and collaborate with these incredibly powerful tools just using language?
That is a fascinating question for the future. Definitely something to mull over. And if you want to explore any of this even further, we absolutely recommend checking out the Google Cloud documentation and the various resources that are linked within the white paper itself.
Yeah, there's a lot more detail in the original source for those who want to go even deeper.
Plenty more to learn. Thanks so much for joining us on this deep dive.